morning, Endeavour. Doug, that song was for you. We hope it sets a good tone for today's inspections.
Good morning, Stan. Just like to say hi to my wife, Karen, and thank her for that song and so much more. Up here, we're all real excited to be starting our trip home, and we're looking forward to another great day in space. Thanks.
Yeah, this is Mission Control Houston. Today's wake-up music for the crew of Endeavour was the song Yellow by the band Coldplay, uplinked for pilot Doug Hurley in honor of his International Space Station fly-around, and looking forward to today's inspections of the shuttle's heat shield systems as the crew gets ready to come home. Hurley indicating that the crew on board is getting excited and ready for the preparations to head back to their loved ones.
Houston, Endeavour, good morning.
Good morning.
Hey, boss, we were wondering if you would mind if we put OBSS on berth in work a little early?
We are ready.
Copy. We'll put this in work then.
Mission Specialist Julia Payette on board Endeavour, reporting that she and Commander Mark Polanski and pilot Doug Hurley are ready to get started on the morning's work on the space shuttle. That's, of course, going to involve the last inspection of the shuttle's heat shield, looking at the starboard and port wing leading edges and the shuttle's nose cap, checking it for any damage that might have occurred since its last inspection on the second day of the mission. For that, they'll be using the orbiter boom sensor system, which you just heard Payette refer to as the OBSS for short. That is a 50-foot long boom that extends the space shuttle's 50-foot long robotic arms reach so that it can get to the points it needs to inspect. In addition, it has several devices that give engineers here on the ground very detailed information about the heat shield and the areas that it's looking at. First is a laser dynamic range imager, which combines an infrared laser illuminator and an infrared camera receiver to build 3D images of the heat shield that can be compared to images of the heat shield that were taken before the flight and also during that that flight day 2 inspection. And then teams here on the ground can search for any differences between the images. And the orbiter boom sensor system also includes an intensified television camera, which gives us the plain black and white TV views we see, and a laser camera system, which is a scanning laser range finder that can be used as a 3D camera or to create 3D computer-generated models of the heat shield. It can replicate features on the heat shield graphically with an accuracy that's within a few millimeters, even if it's as much as 10 meters away from the area that it's scanning. The work today will wrap up the robotics work for the mission. It's been a very robotic intensive mission with steady use of not only the shuttle's robotic arm and the station, but also the first loaded use of the Japanese robotic arm back at the station. Close-up view here of the other end of the orbiter boom sensor system. The robotic arm is grappled to the far end, as you can see at the very edge of the left side of the screen. And here is a closer look at the system of equipment or tools that it'll be using for the inspection today. Again, that includes a laser dynamic range imager, an intensified television camera, and a scanning laser range finder. The television camera provides just plain black and white views, but the other two allow teams here on the ground to get 3D images and also build 3D computer graphics of what they see on the the shuttle's wing leading edges and nose cap, looking for any instances of damage that might have occurred since the last inspection on flight day 2.
Meanwhile, on the International Space Station, orbiting in close proximity to the shuttle at an altitude of 221 statute miles, the 6-person Expedition 20 crew, which now contains flight engineer Tim Kopra, who is taking over for offgoing flight engineer and now shuttle crew member Koichi Wakata. We'll focus on preparations for rendezvous and docking of Progress 34. Gennady Padalka, the commander on board the station, and flight engineer Roman Romanenko will be in the Zvezda service module, watching carefully as the Progress approaches at the manual docking controls for telerobotic control, able to take control of it if for some reason the automated docking software called Coors should not behave as expected.
Москва, МКС-1.
Moscow SS on space to ground 1.
Отвечаем.
Go ahead.
Слава, у вас есть, да, изображение?
Slava, are you receiving video?
Да, есть
Are
изображение.
you receiving everything? Yes, we are receiving video, but we also would like you to provide commentary when possible. Just so we know you're there.
В облете пока дальность 200.
Okay. Well, right now we're still continuing to fly around at 220. Copy.
Close-up view here of one of the Soyuz docked to the International Space Station. Progress and Soyuz are very similar, except for that Progress is not, of course, meant to have people fly inside of it. Carries only cargo to the space station, and rather than being able to land, it is sent to burn up in the station's in the Earth's atmosphere after being filled with trash that the station needs to get rid of.
Да. Гена,
Gennady,
Да.
go ahead.
вот по нашим данным облет закончен, но
It looks like the fly around is over, but we're in the completely wrong configuration. You need to dock manually and transition into the Toro mode. Yes, in work, I'm going to go ahead and assume control. Very good. And I'm going to get into the manual mode. Manual mode activated. Let's do it. Page 25.
Commander Gennady Padalka has the ability to take over the docking of the Progress, although it's also able to dock automatically, and as you can hear, teams in Russia decided that that's necessary for him to do this time.
Подходим.
And I'm approaching.
Станция в текущем положении.
Commander Gennady Padalka beginning that final approach to the space station a few minutes early. We have video for just a little longer now.
I'm in the manual mode.
Принято.
Copy.
Небольшой облет выполняю.
A little bit of the maneuver. The target is not can be seen clearly. Copy.
давай, Ген, спокойно.
Okay, go ahead. Proceed quietly. We still have 20 minutes, and we still have a lot of time. I understand. I understand. And the target is in the center and closing.
Смотри визуально скорость еще на всякий случай.
And monitor closing rate visually as well.
Подгашу, сейчас уберу крест.
I'm going to remove this bias a little bit.
Подгашу еще скорость.
And I'm decelerating.
Принято.
Copy.
Кресты собраны, все нормально.
The cross sections coincide, and the vehicle controllability is good. Very good. Copy. I'm in the impulse mode.
Принято.
Copy.
Чуть право даю.
A little bit to the right.
В режиме идет Мишель, да.
The target is there in the impulse. I'm on the impulse mode, and I'm still decelerating.
И еще подгашиваю.
And still more.
Все, мишень в центре.
The target is in the center. SWP is ready.
Принял.
Copy.
Принял.
Everything is nominal. All right, copy.
Еще небольшой тангаж.
And a little bit of pitch.
Кресты собраны, скорость минимальная.
The rate is minimum.
Принято. Все в центре.
The cross sections coincide. Everything is in the center. Copy.
Подгашиваю еще чуть-чуть скорость.
And
Еще немножко.
still adjusting the closing rate. A little bit more. Copy. And a little bit more.
Плавное сближение, все в центре.
Everything is centered. And I'm closing.
Бортинженер говорит,
0.07.
сотой говорит.
According to the flight engineer. Copy.
Есть касание.
Contact.
Принято касание.
Contact. Very soft contact. Very nice. Capture.
Принято.
Copy.
Сергей, мы тебя поздравляем.
All right, Gennady, congratulations.
Я вас тоже, Владимир Алексеевич.
And congratulations as well. Thank you.
Очень плавно.
Everything is very smooth and very nice.
Управляемость была прекрасна.
And the vehicle controllability was excellent.
Слышите меня?
If you can hear me.
Вот у нас пошла штанга.
And the probe is extending.
Сергей,
And now retracting.
Принято.
And Gennady, thank you very much. Good job.
Спасибо вам.
Commander
Поддержку.
Gennady Podanka at the International Space Station just guided
Yes, we will.
at 6:12 a.m. Central Time, just a few minutes early, the Progress 34 vehicle into a docking at the aft port on the Zvezda service module.
I think it's fine.
As the station and Progress were about 220 miles above the border between Kazakhstan and Russia. Commander Mark Polinsky, pilot Doug Hurley, and mission specialist Julie Payette now starting on the nose cap survey. Completed the starboard wing survey already, and after this, all that will be left is the port wing. Planning to break in between the nose cap and the port wing for a midday meal. The view you're seeing here is coming from the laser dynamic range imager on the end of the orbiter boom sensor system. That again combines an infrared laser illuminator and an infrared camera receiver to build 3D images of the shuttle's heat shield that can then be compared to images from the heat shield taken before flight and during the Flight Day 2 survey of the Endeavour's heat shield. The areas that they'll survey today are those that have the reinforced carbon-carbon. Those parts of the heat shield see the highest temperatures during re-entry of the Earth's atmosphere. It gets up to about 3,000 degrees Fahrenheit. So teams on the ground will take a close look and make sure that those areas didn't receive any damage while the shuttle was in orbit. In addition to this inspection today, they have been working to get things stowed away in the shuttle's cabin, and in particular working to put away the spacewalk tools and suits that were used during the STS-127's 5 spacewalks. In addition to the landing checkouts tomorrow, the crew is also going to be deploying 2 satellites. One, the DragonSat, which stands for the Dual Autonomous Global Positioning System On-Orbit Navigator Satellite. That one will collect data on autonomous spacecraft, rendezvous, and docking capabilities. It's actually made up of 2 picosatellites, which include the AggiSat-2 and Paradigm, which will acquire GPS data from a device provided by NASA, and send it to the ground stations at Texas A&M University and the University of Texas at Austin. Those two schools are co-sponsoring and operating the experiment, and the two satellites are going to be collecting 2 orbits worth of GPS data while remaining in an attached configuration after they're released. The other satellite that Endeavour will be releasing tomorrow is the Andy 2 satellite. That's the Atmospheric Neutral Density Experiment 2, which is part of a Department of Defense project that's trying to provide high-quality satellites for calibrating techniques and models of precision orbit determination. And it will also provide some data on atmospheric conditions for validating Air Force sensors.
This is Mission Control Houston. We are now just a few minutes away from the Endeavour's engine burn that's coming up. You can see Endeavour's tail pointed down toward the Earth. This is so this engine plume will react as expected with Earth's ionosphere. The crew on board Endeavour now set up to fire these engines for about 10 seconds. It will change the speed of the shuttle by 17 feet per second. And the satellites will be watching to see how this engine plume affects Earth's ionosphere. This is part of an experiment called Shuttle Exhaust Ion Turbulence Experiment, or SITE for short. It uses sensors on board a satellite to analyze how Endeavour's exhaust plume will affect Earth's ionosphere. Scientists will take a look at the data and hope to learn more about how these plumes react with Earth's upper atmosphere. Endeavour now firing its engines for 10 seconds. The team here reporting good control, good engines. And the burn is now completed.
Houston, good burn.
This is a replay of some video captured on board the station of yesterday's departure by Endeavour. You can see the reaction control system jets and the other jets on Endeavour being fired as the shuttle performed its fly-around maneuver of the entire complex and then left the vicinity of the station. STS-127 pilot Doug Hurley was at the controls of Endeavour yesterday during this fly-around maneuver. He piloted the shuttle at a distance of about 450 to 600 feet away from the station complex, completing 1.5 circles of the entire station, giving us a very good view of the station and its entire solar arrays, as well as all the modules in the U.S. segment and the Russian segment. Also getting a good look at this exposed facility that was attached to Kibo during this mission. A spectacular shot of Shuttle Endeavour now that was recorded yesterday by the Expedition 20 crew as Endeavour and the STS-127 crew performed their fly-around of the International Space Station complex. At this point in the flight, Endeavour was about 610 feet or so away from the station, just passing directly below the Russian segment. You can see one of the Russian Soyuz vehicles there as it eclipses Endeavour. This now a live view from onboard Shuttle Endeavour. This left OMS engine burn, which you're taking a look at right there, it will be a 12-second burn. It will change the speed of the shuttle by 10.3 feet per second. The OMS engines are firing now.
Endeavour Houston, good burn, no further trim required.
We copy, thank you.
This is Mission Control Houston. We're watching playback from onboard STS-127 and Shuttle Endeavour of today's activities. The crew was busy using the shuttle's robotic arm as well as the orbiter boom sensor system, the 50-foot long attachment on the end of the robotic arm, to take a look at Endeavour's wing leading edges as well as the nose cap. They documented their activities on board the flight deck of the shuttle.
Indeed, and this is the preparation for the OMS burn, the first OMS burn we did today. Photo TV, we got beautiful shot of the burn.
Yeah, we enjoyed your live downlink.
Here's the pilot. And here's the commander. Now, if you watch attentively when they're going to start counting the burn, the cameraman, or woman, will be pushed back a little bit by the acceleration. 3, 2, 1, and burn. Woohoo!
Looks like you were having fun, Julie.
I wasn't there. No, I was.
That is STS-127 pilot Doug Hurley sitting there in the pilot's seat. Up in front of him, you get a clear view of the heads-up display that will come into play Friday morning as he and Commander Mark Polanski steer Endeavour toward its landing on runway 15 at the Kennedy Space Center at 9:48 a.m. Central Time.
Here comes the next clip. This is from dinner last night after we closed the hatch in on dock from the station. We were still in good spirits. Here comes the next clip. This is mid-deck reconfig today, having to deal with all our bags and filter cleaning. So here Chris Cassidy is holding the vacuum cleaner. He'll power it on, and you'll see it spin on its own. Well, unfortunately, the vacuum cleaner has been rescued, and now demonstration of cleaning the house, filter cleaning. And after cleaning the house, exercise. A shot of the airlock from the mid-deck. It's pretty crowded, the space shuttle, when there's 7 people on board and no gigantic space station. is Koichi exercising. And going up from the mid-deck to the flight deck, where inspections are going on. Dave Wolf, cinematographer. And here's the arm, the part of the boom. Back in the mid-deck, we have a new sportsman, Tom Marshall. And Dave, and what he's saying right now is don't do this at home. One last clip for you. This is snowy time on board the Space Shuttle, a water dump. And here Dr. Wolf studying the size of the droplets from the water dump.
Yep, water dumps in daylight, they're hard to beat.
I agree. And here, one last quick tour of the cabin before we sign off for the night. The proverbial FDS locker. And up on the flight deck with payload bay doors to the Earth, the view is magnificent. And with this, Dr. Wolf and the crew of Endeavour, STS-127, bid you good night. Good night, Houston.
That was lovely, Julie. Thanks for all the video Sleep well. Good night to you.
Good morning, Endeavour. Koichi, that song was for you. Classic to start a busy day that will complete some mission objectives and set you and your crewmates up for a return tomorrow.
Good morning, Houston. Thank you very much, and it's another wonderful day in space.
Next up on the schedule is a burn of Endeavour's orbital maneuvering system engines for the site, the Space Shuttle orbital maneuvering system engine exhaust test. That experiment is using space-based sensors on satellites to detect the ionospheric turbulence after the orbital maneuvering system engines are fired, and that exhaust plume crosses path with at least one of the satellites participating in the experiment. And that setup based on radar observations from the ground on previous missions. That will be a 10-second burn of both the orbital maneuvering system engines. That changes the velocity at 17 feet per second.
Endeavour Houston, good config for the burn.
Thank you, Dex.
Endeavour, good burn, no trim required.
We copy, thanks.
The crew on board Endeavour has set up a video camera to look into the payload bay and watch for the deployment of the first pair of satellites that are being deployed today. The DragonSat, the dual RF or radio frequency astrodynamic GPS orbital navigator satellite, which will demonstrate autonomous rendezvous and docking in low Earth orbit and gather information about the GPS system and using a receiver strictly designed for space applications. DragonSat involves 2 Pico satellites, one built by the University of Texas and one built by Texas A&M University. The ultimate goal of the campaign is to demonstrate autonomous rendezvous and docking between 2 small satellites. Each of the Pico satellites within DragonSat has been named by the teams. The University of Texas at Austin satellite is named Bevo 1, and the A&M satellite AggieSat 2.
Houston Endeavour, stand by for DragonSat deploy. 3, 2, 1, deploy. Houston Endeavour, it was a good deploy. MET 143120.
Endeavour Houston, we copy 3120. Thanks very much.
This is Mission Control Houston, a live view on board Shuttle Endeavour now. Endeavour's crew getting ready to deploy another experiment called the Atmospheric Neutral Density Experiment, or ANDE-2. ANDE-2's goal is to basically measure the total atmospheric density between 100 and 400 kilometers up in Earth's atmosphere. There are two different satellites that will be deployed. They're 19 inches in diameter. They're both exactly the same size, but they have completely different masses. One is 50 kilograms, the other one is 25 kilograms. They have retro reflectors on them, which will allow ground stations to track these two independent satellites.
Houston Endeavour, stand by for ANDE-2 deploy.
We're watching.
3, 2, 1, deploy.
Beautiful.
The ANDE-2 experiment now floating in space as it leaves the cargo bay of Endeavour. Again, this experiment consists of two microsatellites, each 19 inches in size, both the same size, but completely different masses. One is 25 kilograms, the other one is 50 kilograms. The two satellites will separate, and due to the fact that they are the exact same size but different masses, they will drift apart over time, as you see them beginning to do now. A team here in Houston celebrating this successful deployment. Scientists and researchers on the ground will continue to watch the two spheres as they drift apart and re-enter at different times, trying to learn more about how different objects with different masses in space behave as they orbit the Earth.
Houston Endeavour, deploy time was 19:19:52.
We copy 19:19:52, thanks.
This is Mission Control Houston. ANDE-2 successfully deployed today by the crew of Endeavour. As they made a pass from Texas to Arkansas, they're now about to cross just to the southeast of St. Louis, Missouri. You see the two perfect spheres of the ANDE-2 experiment there beginning to drift apart toward the right of your screen. Again, these are 19-inch spheres. One is 25 kilograms in mass, the other one 50 kilograms. They have different retroreflectors and laser targets mounted all over the spheres so that teams on the ground can analyze the orbit and the decay of these two objects as they continue to orbit the Earth just below the orbit of the International Space Station, and over time they will decay and eventually re-enter the Earth's atmosphere.
Less than 12 minutes to touchdown.
Endeavour Houston, energy, ground track, and nav are go. Touchdown 2550 at 195.
STS-195, copy the rest, Houston, thank you.
Endeavour, take GPS.
Take a GPS.
The Space Shuttle Endeavour is continuing its path towards the Kennedy Space Center, going through that roll reversal to the right. And the Global Positioning System, or GPS data, is being stored in the primary avionics software system to be used for the guidance and navigation control. Data showing Endeavour flying at 4,900 miles per hour at an altitude of 143,000 feet, with 260 miles to go to the Kennedy Space Center as it crosses over the southwest coast of Florida. About 9.5 minutes to touchdown. Endeavour will be expected to touch down about 2,700 feet from the threshold of the runway at 224 miles per hour. Data shows the vehicle flying at 3,800 miles per hour at an altitude of 125,000 feet. Now 180 miles to go to Kennedy as it continues its path, crossing to the southeast of Lake Okeechobee. About 5 minutes away from the intercept of the heading alignment circle, the imaginary circle that the commander will fly Endeavour around to line up with the runway. Eight minutes to touchdown.
Endeavour, take air data.
Taking our data.
This is a view of the Space Shuttle Endeavour from the Kennedy Space Center as it flies at an altitude of 8,000 feet, flying at 1,600 miles per hour. 6 minutes to touchdown.
Endeavour Houston, you are on energy approaching the hack. Winds are now 7 peak 12 on the nose, 3 peak 5 from the right. Nominal shoot deploy.
Copy, all nominal shoot.
Five minutes to touchdown of the Space Shuttle Endeavour at the Kennedy Space Center. Endeavour flying at an altitude of 60,000 feet. With that update to the winds at the landing site, the expected speed at touchdown is 222 miles per hour. Endeavour is receiving navigation updates for proper alignment and speed approaching the heading alignment cylinder in front of the runway and adjacent to its extended center line. Commander Mark Polanski taking over control of the Space Shuttle Endeavour to fly around that cylinder, conducting a 210-degree turn, a left overhead turn. Sonic booms audible at the landing site. This is a view from the heads-up display in the cockpit of the Space Shuttle Endeavour. Three minutes to touchdown. Endeavour flying at altitude of 30,000 feet at 510 miles per hour.
Endeavour on at the 180.
On at the 180.
Pilot Doug Hurley taking a chance to fly the Space Shuttle Endeavour around the heading alignment cylinder. Commander Mark Polanski back under control of the Space Shuttle Endeavour, setting up for the final approach at the desired heading, altitude, airspeed, and rate of descent.
Endeavour on at the 90.
On at the 90.
Two minutes to touchdown, 17,000 feet in altitude. Endeavour flying at 400 miles per hour. Transceivers on Endeavour are interacting with stations on the ground to provide the best available range, elevation, and azimuth.
KC runway 15's in sight.
Houston copies, field in sight.
One and a half minutes to touchdown. Less than 10,000 feet in altitude remaining. Endeavour's descent rate is 20 times higher and 7 times steeper than a commercial airliner on the final approach. One minute to touchdown. Endeavour's landing gear will be locked down in place at 300 feet in altitude. 30 seconds to touchdown. The landing gear is down and locked. Touchdown. Doug Hurley now deploying the direct chute. And Commander Mark Polanski rotating the nose gear down to the deck. Nose gear touchdown. Endeavour rolling out on runway 15 at the Kennedy Space Center, wrapping up a 6.5 million mile mission. This is the 71st landing at the Kennedy Space Center. Endeavour has completed its 23rd mission and the 127th Space Shuttle mission. It was the 29th to the International Space Station.
Roger, wheel stop, Endeavour. Welcome home. Congratulations on a superb mission from beginning to end. Very well done.
Well, thanks to you and to the whole team. That's what it's all about, and we're happy to be home.
Roman, there are no immediate post-landing deltas, and we'll meet you on page 5-3 of the entry checklist.
Copy that. We're there.
With the completion of the STS-127 mission, Endeavour and her crew have completed 2 major milestones for the Japanese partner of the International Space Station, topping off the construction of Japan's Kibo laboratory with the last of 3 assembly missions, and bringing home Japan's first long-duration station crew member, Koichi Wakata.
Loud and clear, Louie. How are you? Thanks.
Wakata spent 138 days in space for this flight. He was a member of 3 expeditions, the first time a crew member has served on 3 different expeditions, 18, 19, and 20 on board the International Space Station. He spent 133 days on the actual space station, and that brings his total over 3 flights to 160 days in space.
Endeavour Houston for Roman. We'd like you on page 5-8 for rad reconfig.
Okay, working it now. And Houston, if you're ready, ETM vertical doors are coming up.
Chunky, Roger, we're watching the doors.
This is Mission Control Houston. The Space Shuttle Endeavour and her crew resting safely on the runway at the Kennedy Space Center with unofficial observed touchdown times. The main gear touchdown at 9:48 and 8 seconds a.m. Central Time. That involves a mission elapsed time of 15 days, 16 hours, 44 minutes, and 58 seconds. The nose gear touched down a few seconds later at 9:48 and 21 seconds a.m. Central Time. That mission elapsed time is 15 days, 16 hours, 45 minutes, and 11 seconds. And Endeavour had a wheel stop at 9:49 and 13 seconds a.m. Central Time, with the mission elapsed time of 15 days, 16 hours, 46 minutes, and 3 seconds.
Endeavour Houston for Roman, we're ready for ammonia activation on page 5-8. We'll take Bravo to sec on.
That's complete, Houston, and also on 5-4, RJDs are off, the side hatch, drag chute, and landing gear saved.
Houston copies all. And for Chunky, we see the ET doors open. Hide load test is not required today, and we are ready for the body flap.
Copy that, in work.
US-Raumfähre Endeavour ist sicher zur Erde zurückgekehrt. Nach 16 Tagen im All landete der Shuttle planmäßig auf dem Weltraumbahnhof Cape Canaveral. An Bord 7 Astronauten. Ihr wichtigster Job im All war die Komplettierung des japanischen Raumlabors Kibo an der ISS. Endeavour ist nach 16 Tagen im All zur Erde zurückgekehrt. Sie landete am Nachmittag unserer Zeit in Cape Canaveral in Florida. An Bord waren 7 Astronauten. Sie hatten beim Aufenthalt auf der ISS vor allem an dem Forschungslabor Kibo gearbeitet.
Strahlend blauer Himmel und kein Lüftchen über Cape Canaveral in Florida. Ideale Bedingungen für die Endeavour und ihre 7 Astronauten an Bord. Eine butterweiche Landung beschließt die Mission dieser Raumfähre nach über 2 Wochen im All und rund 10 Millionen zurückgelegten Kilometern, gibt sein Lob vom Kontrollzentrum. Willkommen zu Hause und Gratulation für eine fantastische Mission von Anfang bis Ende. Sehr gut gemacht. Dabei lief gar nicht alles so rund bei dieser Mission. 6 Anläufe brauchte die Endeavour, bis sie endlich einen Monat später geplant zur ISS aufbrechen konnte. Dort gab es dann auch einiges zu tun. Allen voran musste das japanische Forschungslabor Kibo vollendet werden. Die Endeavour hatte dafür eine tonnenschwere Plattform mit dem Gepäck. Diese befestigten die Astronauten in mehreren Außeneinsätzen. Dass zeitweise die Toilette der ISS ausfiel und das mit 13 Mann an Bord soll noch am Rande erwähnt werden. Aber am Ende ist ja alles gut gegangen.
Canaveral gelandet. Endeavour hatte bereits am Dienstag von der internationalen Raumstation ISS abgedockt.
The most important thing about a mission is the patch. And the best patches are the ones that have your name on it. Now here's Endeavour. We've done this a couple times by now, so we've gotten really good at walking out. And we're getting off the van, and believe it or not, we're saying this is the one day that we're not going to go. And you could see that it's a little bit tight strapping in as we get the pilot in there. And you could see folks on the middeck, the flight deck crew. And now we're there for a couple of hours, and finally we actually are getting the go as we remove the white room. And this will kind of speak for itself.
We're go for main engine start. We have main engine start. 4, 3, 2, 1. Booster ignition and liftoff of Endeavour, completing Kibo and fulfilling Japan's hope for an out-of-this-world space laboratory.
Houston, Endeavour, home program.
Roger, roll, Endeavour.
The camera views we have now are just amazing. Always a great moment when the solids separate, and you can see here that we have main engine cutoff for MECO as we finally achieve orbit and weightlessness, and what a great feeling for everybody. Here's a great shot that was taken by Chris Cassidy of the tank as we photograph that before it re-enters. Remember, it's the only part that does not get reused. We open up the payload bay for the very first time, get our view of the planet out the back window at the same time that we see everything in our cargo bay. Here's a wonderful first view of our beautiful Earth. And there's Tim Copra, and there was Tom Marshburn, Julie, folks very quickly getting ready to go to work, Doug Hurley. We haven't been up there very long. And after a couple days, it's time to go ahead and find this thing called the space station. So fortunately, I didn't lose it. Here's a great view of what we carry in our payload bay. This is the going to be the exposed facility, the Jeff. That's the jelly we'll attach to it. We'll see it later. And this is something called the ICC Integrated Cargo Carrier that has several payloads and batteries. I believe you could tell that this is just slightly sped up, but performed a valuable role for this great photography of our underside to make sure that the team on the ground can determine that our vehicle was in a good condition for entry. Hard to believe that we actually did this. But it was phenomenal. And here we are coming aboard. We're going to go ahead and dock right there on the space station. And as we come aboard, you'll see some of the targets that we lined up. You have a crosshair right here that we use for visual alignment, and it's blurry here, but in the camera it tells you that we're pretty much aligned. As we go ahead and open the hatch, and we have a very excited station crew of 6 on board waiting to welcome us.
Let's take a tour of the International Space Station. It is absolutely huge. Here's a view from the commander window. We saw the Japanese module. That was the European module. Here's part of NASA's Node 2, and at the very top there, one of the Canadian robotic element. So we go down. Oh, taking care of cables in weightlessness is not fun. We turn a corner into the shuttle airlock and then turn another corner into the space station. You have to do a bit of a 90-degree turn in order to realign yourself. This, of course, is a little sped up again. Here's Koichi Wakara, that was really glad to see us because we were his ride home. This is the European module, Columbus. We turn around, and we're seeing Bob Thirsk inside the Japanese module, with which we worked extensively. And particularly, there is a small closet up there and 2 windows that are absolutely great. Watch. That's what you see. Unbelievable sight. Especially when we had our spacewalkers out there, we could see them like if they were real close. We continue on through the Node 2 and into the main lab, Destiny, the US lab. This is it looks like a closet, but it's actually a sleep station. Each crew member that stays on station for several months has a place to sleep and put their things. Tim Copra, who came up with us, is already exercising. There's Frank Devine from Belgium. We couldn't help it but to stop and look at the robotics workstation because we were going to spend a lot of time there. Continue on, exiting the lab into Node 1. one of the first modules that was brought in space in 1998. And here's a view of the airlock where our spacewalker were already busy taking care of their equipment. And now we're passing from the US part of the station into the Russian part. This was one of the Soyuz capsule to return to Earth. There's Roman Romanenko, one of the Russian crew member, through the FGB, a Russian cargo module, into another pathway to go to yet another Soyuz capsule. This is the vehicle that some of the station crew members take to return to Earth. There's the commander of station, Gennady Padalka from Russia, where he was doing an experiment, and this is the very tip of station. We'll turn around one last time so that you can see. It's the size of 2 football fields from one end to the other. But we didn't have much time to explore. We had to go to work right away. First thing first, we had to install the exposed facility, which of course was way too long for us to talk about, so we called it the JEF. But really what it is, it's a exposed facility, it's a port. In order to get it on station, we had to pick it up with one arm, pass it to the other, and then pick it up with the same arm that was used to pick it out of the cargo bay. Quite a complicated robotic ballet, which was devised by our almighty flight controllers and planners on the ground. This is extremely sped up. We don't operate big pieces this fast. So when it was properly aligned, and this was practiced on the ground several times, Doug Hurley and Koichi Wakata aligned it up and installed it, and here it was in its final position. It's still up there. Well, we had to do this kind of handoff of pieces of our cargo bay 3 more times in the mission. So we picked up a piece, we handed it off to the other arm and installed it on station. Here comes the Jelly, which carried 3 Japanese payload that we would then use the Japanese arm. First time we would use it in an operational manner to pick up those payloads that would be installed on the exposed facility to do science in the vacuum and space for months to come. We had 3 of those payloads, so we had teams. Each payload was done by a different team of robotic operator, and you see them right here, and installed one at a time over the course of 1 day onto the exposed facility. And here's the Jelly empty. It then got picked up yet again by the big arm, given to the shuttle arm, and put back in the cargo bay to come back home with us.
So in order to pull off 5 EVAs, we had a 4-people team, Tim, Dave, Tom, and myself. You can see on to make a flight day 4 EVA happen, which is a day after undock, there's a lot of equipment that needs to be transferred immediately, and that earlier picture was Dave doing just that. Getting the folks in the crew lock is no small task. They're 2 big, cumbersome guys in the suits, plus all the umbilicals, and routing those umbilicals so we don't get all tangled up took us a few learning curves, but we got it. A lot of integrated robotics on this mission, which is very communications intensive, which we practiced for quite extensively on the ground. You can see Doug and Julie would drive Dave around on the arm, this here on EVA 2, as he's going into position to grab some of the large ORUs that will place to their storage platform on the station. Down here you can see Tom through Dave's helmet camera as Tom's getting in alignment to help provide clearance views. This is the S-scan antenna, which gave Dave nightmares prior to launch as he worried about that banging that antenna. Dave likes to say that he's happy he lives in the future where the antenna is in good shape, not the other future. Here's Dave installing the pump module. This is an interesting piece of equipment because the module itself is larger than the platform that it sits on, so it's difficult to see the alignment as he puts it in there, and it took a lot of coordination between Tom and Dave in order to pull that off. the next phase of the EVAs got into batteries. And here you can see two of us working with the batteries. They're about 5 feet by 5 feet by 2 feet or so and weigh several hundred pounds. And they actually move fairly well and stable once you get them out of their attachment spots. But they did require a significant amount of force. That force switch you can see makes the arm oscillate. And that's what gave Julie and Doug their nightmares. So we would do a technique called a shepherding or handing it back and forth. And this is MLI. We heard earlier a group gave an award for that, and I'm sorry to those folks that I had to throw your MLI overboard. This is a view out the Japanese window as on EVA 5 when Tom and I were out there working on some cameras to install as well as prepare some handrails for later use. This is a view of the small camera that we installed. And you can see the safety tethers that we use strung along, and that's where you have to pay particular attention to making sure those are straight and don't get tangled.
Well, it's hard work to work in a spacesuit, but it's easier inside where you aren't encumbered by that pressure suit. Living in space is an acquired, learned talent or art. Some people are better at it. These guys are really good at it at this point. Julie's very good. There are some collisions. Definitely don't try this at home. You can lose track of the ceiling and the floor if you don't pay attention. It's kind of fun to do. Sometimes it feels like you're crawling up out of a manhole or diving straight down. Meals are a lot of fun. The pressure comes off. You hear lots of languages in this space station. It's very international. Foods from many countries, music from many countries. It's really a very interesting meeting ground between people, and the discussions and philosophy that is exchanged between the work is pretty fascinating. It definitely does bring the people from many countries together. It serves that purpose. The food is rehydrated, kind of like camping food. It's extremely good. That's pretty dangerous, Roman. Roman had his specialty breakfast tacos there. They're glued together with taco sauce and eggs. You got to get the mixture just right. You have to maintain this space station and spacecraft just like any other home. I hear you vacuum at home. Doug, please.
Okay, the end of the docked phase of the mission, saying goodbye was hard because we had a great time with all our friends, but we felt like we had accomplished everything we set out to do, and here we go. Mark gave me the keys to Endeavour, and I got to do the undock and fly around. Some of the most incredible views I've ever seen in my life. You can see the shadow of Endeavour there in the solar rays. Obviously slightly sped up. Not a lot though, I flew it pretty fast. There's a view from space station of us doing our fly around.
We actually did not feel we'd had enough to do on this mission, so we were able, on the day before we came home, to deploy a couple of satellites. That satellite was actually designed and built by graduate students from Texas A&M and University of Texas together. This is a Navy satellite we also deployed. It actually was supposed to come apart, as you see here. And it was good that we had studied up on that so we knew what to expect. There's another satellite that's about to come out of the canister there, and it offered just wonderful views as well as some good tracking and data for the investigators as well. And you could really see orbital mechanics in work there. It was a beautiful sight. The mid-deck team put together a great deorbit plan for us. Here we are on landing day. I got to join the flight deck crew for the landing. We're all very excited about coming home at this point. That's tendrils of plasma that are coming up over the overhead windows, about 3,000 degrees on the outside of the orbiter at that point. We're just starting to feel the beginnings of any acceleration, some G's. There's Roman demonstrating that with one of his cue cards. I thought we were experiencing about 10 G's, and Roman said, okay, there's 0.1 G now. And it really, really hits you pretty hard, but it's very fascinating. The re-entry is very fast. It seemed it was seconds between Central America, Cuba, and then suddenly over Florida. You know, all commanders say that they fly some pretty good landings, but if you ever really want to know, just talk to the mid-deck crew and the rest of the crew. And I'll have to say that no one actually knew that we had touched the ground. It was such a smooth landing. And our families were very happy to see us come home. We were happy to be able to see them here pretty soon. And then finally, we had a chance to walk out and see our orbiter. Everybody was feeling remarkably well. I think every now and then I needed a little help to make sure I was standing up straight. There's Chunky helping me out a little bit. But everybody was looking real good. And so again, thank you to everyone. That's our video presentation tonight.